So first thing I want to do is kind of prepare you for what I'm going to teach you. There's this idea of a differential, and this is mostly going to be approaching this more of a sort of like a bookkeeping device. So like on the integral, you have the dx, the dt. I'm going to kind of show you sort of what that is. And what we're looking at on a differential, and this will again be preparing you for what we're going to do in the integrals here in a minute, is if you're given a function and you're finding dy, okay, what you're really doing is it's telling you to find the derivative of y, and then the variable is x. Okay, so what I'm mostly showing you is how to keep your variables kind of consistent. Okay, so what you're going to do with this one is, and this is simple to do, what is the derivative of x to the third? That ought to be just a piece of cake. 3x squared, right? So what you're going to say is dy equals 3x squared, but you also have to put this differential dx on it like this. So like if you're doing an integral, once we get into the very last part of this chapter, we start kind of seeing what integrals do. They have something to do with areas under curves. Then it'll be a little bit more clear what that is. But when you're doing dy, which is a differential, you do the derivative, but you also want to add in that thing right there, okay? And that's mainly all I can explain right now is that's more of a bookkeeping device that we're going to use in our integrals, okay? The next one, you're finding du. Okay, so when we do du, well, the variable is x. Okay, and let's review this. Okay, you need to be sure that you know how to handle a logarithm with a chain rule. What's happened to my pen all of a sudden? Derivative of this. Okay, now we've learned how to do a derivative of a log. How do you do a derivative of a log like this? It's two steps. 1 over the function, then what? Derivative. That's chain rule. So you want to write this like this. This is 1 over the function. Okay, and then this is chain rule because there's something other than just x, and that derivative inside is what? Negative 2x. But you got to have the dx there. So I'm introducing to this idea of a differential. See, we're not really doing du over dx. We're doing du. Okay, so we have that. And then you could write this as, just the best way to write it is negative 2x over 4x squared dx like that. All you're doing is you know how to do a derivative, but just tie in that differential piece there. And you'll get a better understanding of what this means a little bit later. Okay, the next one we're going to do dv. Okay, well, all you're doing is the derivative of that. Okay, how do you do the derivative of e to the negative 6t? It's itself, and then what? Derivative of exponent, right? Okay, so you're going to have the 10. You want to write the 10 down. And then you have e to the negative 6t. And then what's the derivative of the exponent? Negative 6. But you also have to tack in dt. Okay, so you're always using whatever that variable is, like that. So you want to write this like this. dv is going to be, and then you have 6 times 10, that would be negative 60, e to the negative 6t times dt like that. Okay, then that would be how you would write that differential, like that. So you're just applying derivative, but put the correct notation. It's always the variable. So I'm going to have you guys do the next 4 problems yourself, but like on number 1, your variable's x, so you're going to have a dx at the end. On number 2, what's your variable? T. So what are you going to have? dt. Okay? So just a little review on your derivatives. Go ahead and do the next 4. I'll give you a few minutes to run through that yourself and see if you're on track with this. But you got to be able to... All right, let's go ahead and see if we got on top of this. Okay? Number 1, what's the derivative on this one? 3x squared minus 4x plus 1. What do you put at the end of this? dx. Good. Okay, just kind of put it at the end like that. Okay? All right. What's the derivative of the next one? Okay, it's itself. E to the t squared minus 2t. Then what? Then you got to do the derivative of the exponent. Derivative of the exponent is 2t minus 2. And what goes at the end? dt. Okay, just got to add that extra piece to it. Okay, you already know how to do the derivatives. Okay, how do you do the derivative on number 3? Chain rule. Okay, so you're going to bring the 4 down. You'll have 2x minus 3 to the third. What else do you got to do? Times 2. Derivative of what's inside. Derivative of 2x minus 3 is 2. Then you have what at the end? dx. Okay. All right, you know what? I made a mistake on that. I'm glad you said y because I just see my mistake. This should have said h of x. Okay. The variable is x on this. See, those things got to match, like g of t and t, f of x and x like that. Yeah, so that's dx. And then I would probably write this as 8, just to simplify it, times 2x minus 3 to the third times dx like that. You guys remember how to do the derivative of the log? This isn't ln. The derivative of ln is 1 over x. This is slightly different. You remember what it is? 1 over t. What else? ln of 10. Okay? Because see, this is a base 10 log. Remember, we had that kind of rule that you do, if you do a log of any other base other than e, then you also have to tack that in like that. Okay? And then what would come at the end? dt. There you go. Okay? We don't see that one very often. It'll show up occasionally. ln is what you're going to see most of the time. Okay. So, you're doing a derivative and then you're tacking that piece in. And when we do what we call a integral by substitution, you're going to do this quite a bit. Okay, now what I'm going to do is kind of show you how to do what's called u-substitution. And the idea on this is we don't really have a chain rule for an integral, but we can kind of deal with it in sort of a similar way. And we're going to do what we call a u-substitution, a change of variables on this is how we're going to do this. Now I'm going to give you some examples. I'm just giving this to kind of take you through the steps you're going to do. But I'm not going to read that off because it ain't going to make any sense anyway, okay? You got to see examples before that makes any sense. So here's the idea. Remember, you kind of have a limited amount of things you can do with an integral. You got basic antiderivatives and you got the power rule. So this thing right here, a little while ago, when I had you guys do something like that integral, well, what did you do? You multiplied it out, so you could do the power rule. At this stage, if you didn't know what I'm going to teach you now, your only choice would be to multiply that out 99 times and then integrate each part. Okay, you could do it that way. Thankfully, there's an easier way to do it. There's a substitution. Now, listen very carefully because a lot of times students struggle a little bit to catch on to this. The thing that you have is this is the key, and this is important. You're going to pick part of this expression for u. But whatever you pick for u, the derivative should be the remaining part of the integral. So here's what I'm saying. I'm going to show you what to do correctly on this to kind of help you see this. So what I'm going to do is I'm going to just highlight that, and I want you to write down, we're going to let u, we're changing the variable, we're just going to let that equal to x squared minus 1. Okay? Now, I'm going to highlight the rest of the integral. That's what's left over is 2x dx. Don't worry about the 99. That's okay. So, what is the derivative of x squared minus 1?
2x.
2x, and it's 2x dx. You're doing a differential like I did there. Okay, so the idea is when you do du, you're going to do that derivative, it's 2x dx, like that. That's the idea. That's the correct way to have u, because when you do the derivative, it's everything else. Okay, if you don't set the u equal to the right thing, then it wouldn't work. Okay, let me, before I finish the problem, let me show you this real quick. And you get to a point where it's not too hard to see this, but let's just say let's say that you let x be 2, or u equal 2x. Then the rest of the integral would have to be what I highlighted in blue. Well, there's no way, right? You're not even close. Okay, so they're designed a certain way. Whatever you use for u, the derivative of that should be what's left over. Does that make any sense? Okay. Sometimes it takes a little time for students to grasp this. So let's do this. We got x squared minus 1, and you got du equals 2x dx like that. So what you're going to do is this right here gets replaced with u. That's going to become u to the 99th. What I have in blue, that's going to be du. So what you're going to end up with is you're going to end up with an integral. You want to write this down. We're going to have u to the 99th times du. Okay, now you want to end up with an integral you know how to do. If you end up with an integral that you don't know how to do, then you haven't done it right. Okay, do you know how to do this integral? Yeah, what is this integral? U to the 100th over 100, right? Okay, it's a power rule. Okay, so what we go ahead and do is we go ahead and do that integral. So that's u to the 100th over 100 plus c. But the thing is, we don't want our answer in terms of u, we want our answer in terms of x. So actually all you got to do to finish it up is u is this, so you plug it back in and then you have the answer to your problem. Okay, so the final answer to the problem would be x squared minus 1 all to the 100th power over 100 plus c. That's the answer to the problem right there. And I'll show you why. We're going to do a derivative and check that it's the right answer. Okay? Does that make any sense what I did? Okay? All right. Now let's go ahead and let's check and see if we're right. Okay, so let's do the derivative of this. How would you do the derivative of this answer? Just do the chain rule, right? Okay, you have a constant right here. You have 1 over 100, so you would just write the constant down. And when you do the derivative of this piece that I'm highlighting, well, what are you going to do? You're going to bring the 100 down, right? Okay, you're going to leave that alone to the 99th power, but what else do you got to do by chain rule?
2x.
Derivative of what's inside, which is 2x. Now notice the hundreds cross out, and if you look at this thing right here matches what you started with. See, it's got 2x and x squared minus 1 to the 99th. So that's why it's the right answer. Okay, so you got to do this by a substitution technique. A lot of times when the integrals get more complicated, this is what you have to do. Now there's, like when I teach Calc 2 at CCD, there's all kinds of different techniques we use. This is about the last technique we teach in this level of a class, so that's how that goes. Okay, now the next one's got something. I want to change this slightly. I want you to just cross out the problem, because I want to start simple here. I want you to write this as integral of 2x e to the x squared dx. I just want to add a 2 in there because I'm not quite ready. You can do this problem as it is, but I'm not quite ready to go there yet. Okay, one thing that you got to do on here, in general, if you see an e in your problem, you're hoping that you could ultimately just change this into an e to the u integral. How come? What's the integral of e to the u? E to the u. So you hope you can change it into that. So what we're going to do is we got to figure out where our u is. One way to do this would be, let's let u be that. Okay? That way we would have e to the u. Okay? But next question is, if you did the derivative of x squared, would you get what's left over? That's what I highlighted in blue. What's the derivative of x squared? 2x. So that looks like that's the right way to do it. So what we're going to do is we're going to let u be x to the second. Okay, like that. Okay, now what's du? Don't forget the dx, okay, because you got that's kind of a bookkeeping device, mostly like that. So that's the correct way to do this. Now you want to look carefully at how I'm substituting in. You get a temporary integral in terms of u. So you're going to have e to the u, okay, and then 2x dx is du. See, all you're doing is just replacing u with x squared with u, and then 2x dx with du. That's it. Now, what is the integral of e to the u? E to the u plus c. Don't forget the plus c. Okay, now, I don't want that answer. I want the answer to have x's in it, so what do? You substitute the u back in. Okay, your final step is always going to be plug that back in because your answer needs to have x's in it. So your final answer is e to the x squared plus c. That's your answer right there. Okay? All right, how would I find out if I'm right? Take a derivative. That's incredibly important. It's the way you ultimately understand all this stuff. So let's do a quick check. So let's do the derivative of e to the x squared plus c. Okay, let's see if that takes us back to the beginning of the problem. Okay, what is that derivative? That would be itself, right? Then what? Derivative of exponents 2x. Okay, and then the derivative of c is 0. Remember, we're checking. Does that take you back to the beginning? 2x, we got it. E to the x squared, so we're right. Okay, so the thing is, the whole key to this is getting your u set up the right way. And we're going to try to start kind of simple on these to begin with. Okay, I'm going to do a couple more. And usually it takes a while to catch on to this. Okay, so remember, whatever you set u equal to, it's got to be whatever's left over in the integral. Okay, so what you want to do is think about what you could set u equal to, and then if you did the derivative, it would be what's left over. Now I'm going to do it wrong on purpose, okay, just as a good way to teach this. Let's just say that I'm going to let that be 5. Well, then what would du be? What's the derivative of 5? That's a bad idea. Okay, you don't have that. What do you think? That's the best way, okay? And see, even if you just did 5x, see, this is where you got to be careful, or I'm sorry, if you let u be just 5x, well, then you would have the derivative of 5x is 5 dx, but you wouldn't have your 6 accounted for. Everything's got to be accounted for, see? And you also got to end up with an integral that you know. So let's do it the right way. Let's let u be 5x minus 6. And I'm going to highlight that in yellow. That's going to be the u part right there. Okay, so tell me what du is. 5 dx. Is that what's left over? It is. Okay, so that part right there, the 5 dx, gets changed into du. So see, everything is accounted for. Now what the integral is then is 5 dx becomes du. The denominator becomes u. That's how that goes. Okay, now remember, you've got to end up with a simple integral that you can do. What this really is, you might not recognize it, but if I write it this way, I think you will. Okay, do you recognize that integral? Do you know what that integral is? ln of u. Okay, remember that if you take the derivative of ln, you get 1 over u. So that's going to be ln absolute value of u plus c. Okay, now I'm not done. There's one step. You know what the last step is? Yes, the last step's always the same. Whatever u is, you got to plug it back in because you don't want your answer with u, you want your answer with x. So the final answer is ln 5x minus 6 plus c. Okay, so that does the problem. Let's just do a quick check. Most of these are easy enough to check and verify that you're right. Okay, all right, well, let's go ahead and do a check and see if it works out. Okay, so let's just do the derivative of the answer. I'm just kind of doing this in my head. So if I was doing the derivative of ln 5x minus 6, how do you do that derivative? 1 over the function, and then what? Times derivative of function. Yeah, so that would be 1 over 5x minus 6. The derivative of that is 5. Does that take you back to the beginning? It does. If you look at the original integral, you have 5 over 5x minus 6. So see, we have to have done that correctly then. Okay? All right. So that's how that one goes. All right. So let's see kind of if we're catching on. I'll let you try some of these in a minute and see kind of where you're at with this. Okay, so if we look at the next one, you got to figure out what to let u be equal to. Now the thing is, when you take the derivative of u, it should end up being everything else in the integral. So what do you think? What? 1 plus d to the 4th? Let's try it. I mean, sometimes you just have to try it. It's the only way. Okay, so the idea is if you just let it, you can't let it equal the square root of that because it'll end up with a big mess. Okay, so what the idea is, if we just let u be that, then we would end up with a integral of square root. Can you do the integral of a square root of u? Yeah, because it's just u to the 1/2 and you use power rule. Okay. if you do du, do you get 4t cubed dt?
Yes.
Yeah, so that's got to be the right choice, see. Okay, so that's the idea. See, what I have in yellow is the u. Okay, now when you do du, you're going to get just 4t to the third dt. Okay, so that's what you're left over with then, see. Okay, so what you're ready to do now is you're ready to rewrite this like this. Okay, so what you're going to have is square root of u. That's the yellow part, that's what u is. And then the 4t cubed dt is just du. Okay, does that make sense? This is always very hard for students to catch on to from experience teaching this. All right, how do you do that integral? U to the 1/2, right? Okay, then you want to do a power rule, so you want to go ahead and do that. So that's u to the 1/2 du. Okay, so when we do that, that's going to be u to the 1/2. You're going to add 1 to it. Okay, then you're going to divide by the result like that. Okay, that's power rule. Okay, so then what you're going to have, what are you going to do with the 3/2? 2/3. Dividing by a fraction is multiplying by a reciprocal, so that's 2/3 u to the 3/2 plus c. But I'm not done because I got to now substitute back in. So you want to take the u and you want to plug it right in there to the end, and then you got your answer. Okay, because you always have to end up with the problem that way. So you have 2/3, and then you have 1 plus t to the 4th to the 3/2 plus c. Okay, so again, I'm replacing the u here with what I substituted for at the beginning of the problem, because you want your answer to have the right variables in it. So that would be the answer. You can check it, and it'll definitely check if you do that the right way. Okay, do you guys understand how I'm figuring out to choose for u? Okay, see, the thing is, when you're doing these, you want to end up with something like this. You would want to end up with like u to a power, because you know how to do that. You might want to end up with e to the u, because that's easy. Maybe you want to end up with 1 over u, because you know that. You always want to end up with an integral that you know how to do. Okay? All right, the only way to see if you got this is just give it your best shot. Go ahead and try the next two and see what you get. I'm trying to make these pretty straightforward, but remember the key is whatever you get for du should be whatever's left over. And you want to end up with an integral that you know how to do. Now let's practice this a little bit. It's a little easier. You start getting a little quicker at figuring out what to set things equal to. Okay. So let's go ahead and kind of put together this first one. So again, the idea is if I let this be u, then I would end up with an integral of u to the 8th. Okay, that's easy to do. Okay, so what we're going to do is we can set this equal to x to the 6th plus 2. Now, I'm going to highlight in blue what I'm hoping du is. What is du? That's what it is, see, okay? All right, see, the problems have to be designed so this works, so that you got that. That's how you should have started that problem. Now, what your integral is what do you end up with? Okay, you've got the part I have in yellow just becomes u to the 8th. The part I got in blue becomes du. Okay, what's the answer to that integral? U to the 9th over 9th plus c. Okay, and then what's the last step? Plug back in. Okay, you want your answer to have x's in it, not u's. That's an intermediate variable is what it is. So you would end up having on this x to the 6th plus 2 all to the 9th over 9 plus c. Okay, so that is your final answer to the problem. If you do a derivative, it'll take you back to the beginning if you do it right. Okay? You got any questions?
What's the purpose of the du part then?
It's more of a bookkeeping device. That's what I've been saying a little bit. You really can't explain that to students well until you learn how to do what's called a definite integral. So it's just, for now, think of it as notation. Okay. I always say when you teach calculus, you always have to kind of explain that. Just wait. I'll get into that a little bit next week, and it'll help you. Yeah.
On this one, Professor, what happened to the 6x to the 5th.
Oh, it's absorbed in your substitution. Okay, see, that's what du is. Okay, so what I did, see, at the end, what I did is u became the part in yellow. So you got u to the 8th. 6x to the 5th dx became du. Everything is accounted for. That's the key. Okay, it didn't disappear because it's a part of the substitution. Okay, it's just that everything has to be accounted for. Okay, all right, the next one, let's see. Let's set u equal to t to the 3rd. Okay, again, this part right here is going to be u. And you're hoping that you end up with an e to the u integral, which you can do, right? See, if you see an e in your integral, you're almost always going to let the whole entire exponent be u, because you're going to end up with an integral you know. Now, again, we hope that du is 3t squared dt, is it? Yeah, okay, The derivative of t to the 3rd is 3t squared dt, okay? So you were asking a minute ago, where did something go? Well, it's in the substitution. This part in blue is going to become du. See, everything's accounted for, everything. That's the key. So what you end up with is e to the u, and then that part in blue becomes du. Okay, when you have u and du established, it needs to be everything that's in the whole entire expression. So that means the answer to this integral is e to the u plus c. And then the final answer is what? Yeah, that plugs back in. So you get e to the t to the 3rd, which is kind of weird, plus c. That's it. Okay? Students, a lot of times when they first learn this, it goes like that. Once you get the hang of it and know what you're doing, how to do the substitution, it's not bad. But this is one of the areas of integrals that takes a little time to absorb. Okay, now what we're going to do now is we're going to do one more thing with this. And we're going to be, our du is going to be off by a constant. So this is one other thing. This is as complicated as it gets in this class, is the idea is du could be off by a constant. It could just be the same, but maybe it has a times a constant. Okay, so I'll show you how to do this first one here. So what we're going to do on this one is we're going to set u equal 1 minus 4x to the 3rd. Okay, now my thinking on this is, see, if I end up with a square root of u, I can handle that because I could change that to u to the 1/2, bring it to the top, making it u to the negative 1/2, and I can integrate. Okay, so the thing that happens on this then, if this is u, this is going to be slightly different than the problems we just did. We're hoping that du is what I highlighted in blue, but it isn't. Okay, what is du? What's the derivative of this? Negative 12x squared dx. It's close, but it's not quite there, okay? So what you could do on this now is when you do this problem, probably the best thing to do at the beginning, and this is not always the case, but it's a good idea to just start by bringing constants out. And I'm going to have you do that. Go ahead and just rewrite the problem as 2 times the integral of x squared over square root of 1 minus 4x to the 3rd times dx. Okay, you can take constants out. But the thing that we have on this is there's the u. What I'm highlighting in yellow is the u. Here's the du. Du doesn't match, but we can make it match. This thing right here is an equation. So what could you do to this equation that would make that 12 go away, so it would just say x squared dx? To both sides. That's an equation. How do you make the 12 go away? Divide by it, exactly. So what you can do is you can divide both sides of this equation by negative 12, and then we have this. And then I'm going to write this as negative 1/12 du equals x squared dx. Okay, this is a slight, one extra little piece that you got to learn how to do when you're doing u substitution. Now, why does this work? Okay, the reason is, now we're looking at this integral, not this one. Okay, notice that we got that whole thing right there as u. We got that accounted for. And then x squared dx is this. Okay, so we're ready to plug in. Your integral, you're going to have the 2. That's going to be u. x squared dx is going to be this. So everything's accounted for. So now what you would have is this integral. So you want to write down your u integral. So x squared dx. What is x squared dx? It's this. X squared dx is this now. So you want to replace that with negative 1/12 du. Okay, now go to the bottom. Okay, you got u as the part that I highlighted in yellow, so that's going to be square root of u like that. See, what will happen is sometimes du will not match, but it'll be off, but it'll have a constant you can get rid of, because this is an equation. Does that make any sense? Somewhat? Okay. Now, let's finish this off. Now, the way you could finish this off is like this. This negative 1/12 is a constant, so it's going to come out of the integral. What you want to do is just pull that out. You still have the 2. You have negative 1/12. Then you're going to have the integral of, I'm going to just write this as 1 over square root of u du, because we can do that integral to finish this up. Okay. This reduces to 1/6. So now I have negative 1/6. I have the integral. Now see, that's u to the 1/2, and I can bring that to the top to write that like that. Okay, I'm just kind of reworking things so I can use the power rule. The only slight twist of this problem was the du equation didn't quite match. Okay, once you get to this point, and this is the hardest part of the problem, is getting to that point, then you can do that. So let's finish it up. So we have negative 1/6. How do you do the integral of u to the negative 1/2? Power rule. Add 1 to the exponent, divide by the result. So that's power rule. So what you're going to have is u to the negative 1/2 plus 1. So I'm going to use 2/2. Okay. The result of that is 1/2, so I divide by it. Okay, then I have the plus c in there. Okay. Well, what I really have is negative 1/6. Dividing by 1/2 is the same thing as multiplying by 2 over 1. And then u would be to the 1/2. The exponents add up to 1/2 plus c. Okay? 2 things you could do to finish this up. One thing is the 2/6 reduces to 1/3, and then you got to plug back in the u. So u is this. You want to plug back in that u from your substitution. So the final answer is going to be negative 1/3, and then 1 minus 4, and let's see, the u was 1 minus 4x to the 3rd to the 1/2 plus c. That is your answer. That gets pretty tricky, doesn't it? But the key thing is that step with the du, you're going to be off by a constant, but you can still deal with that. That's the answer. It checks too. If you did a derivative, you would tell that it checks. Okay? All right. I'm going to keep working on this because you got to just kind of see how these go. Then you got to try it, and it's the only way to learn it. Okay, this one right here, I'm going to let u be this, 10x minus 3. Now let me give you kind of what my thinking is on this. Okay, if that thing becomes u, can you do the integral of 1 over u? Of course you can. What is the integral of 1 over u? ln x, okay? All right, now what we are thinking now is we're hoping du is what I highlighted in blue. Or we're hoping maybe it's just off by a constant. It's close, in other words, okay? So what is du based on 10x minus 3? It's 10 dx, right? Okay, I'm going to erase some of this stuff from the last problem because it's kind of getting in the way here. Okay, like this. All right, let me just kind of pause there because what we have so far is we have u there. We have that. Now, here's the thing. We wanted du to be 1 dx, right? It's 10 dx. So how do we make 10 dx become 1 dx? Divide both sides by 10. Okay, so that's what you do. Remember, this is an equation, so you just divide both sides by 10. And then we're going to write this like this. Just write this as 1/10 du equals 1 times dx. Okay? Now, we got everything here. So in your integral, u is this. What are you going to replace the 1 dx with? 1/10 du. Now everything's accounted for. So see, it goes like this. This part right here is going to become 1/10 du. So now you've got everything put together. This problem will probably maybe look a little simpler than the last one to you. So what you end up with is the integral of, now see, you're going to have over u, like that. Okay, that's the u there. And then the part in blue gets changed to 1/10 du, like that. Everything's accounted for. The only twist is the du didn't match, but we made it match. Okay, that's the idea. Okay, 1/10 is a constant. What can you do to constants? You can bring them out of the integral. So that would give 1/10 times the integral of 1 over u times du. Remember, you want to end up with something that's an easy integral for you to do. So what's the answer to that integral? ln of u, good. Okay, plus c. So that is 1/10 ln of u plus c. Last step is always the same. Whatever u is, plug it back in, and then you're done. Okay, so the final answer would be 1/10 ln 10x minus 3 plus c. Take a derivative, middle check. Okay. All right. Good, bad? Getting better? No? U-substitution is hard for students to learn. It always is. You got to work with it. Okay. All right. Let me do one more, then I'll kind of guide you through a couple more of these and see if you can get through them. So let's see this one. What do you think? Just look at it for a minute. What do you think would be a good u? Remember, you take the derivative, it should be close to what's left over. The derivative of x the third is 3x squared, so you have an x squared in top. So let's try this. And again, sometimes you just have to try it. So let's try this approach. Let's let u be x cubed minus 3x plus 7. Okay, now remember what we have here is by doing that, if you had a 1 over u integral, you could do it, right? Okay, so it's okay to have 1 over u. Okay, now again, we're hoping du is what I highlighted in blue, or close. So what is du? 3x squared minus 3 dx. It's pretty close. Okay, the question becomes, how do you change this thing into that thing? Divide by 3, exactly. Divide everything by 3, okay? So what you can do is that. You can just divide this side by 3, and you can divide that side by 3. Now see, that's what you almost always do. If it's off by a constant, just get rid of that constant. So that's going to give 1/3 du equals x to the second minus 1 dx. Okay? So see, we make it happen. We make the substitution work. So then what you're going to have is when you put together the u integral, this intermediate integral, then x squared minus 1 turns into 1/3 du. So that right there is going to be your 1/3 du. Okay, we got our u. That's what's in yellow. The part in blue is 1/3 du. Okay? All right, so your integral is going to be this. It's the integral of 1/3 du. That's the part in blue all over the part in yellow. Okay, everything is accounted for. Okay, we got u and we got x squared minus 1 dx. We got that. All right, what can you do with the 1/3? It's constant. You can bring it out of an integral. So you have 1/3 integral of 1 over u times du. Okay, like that. Okay, what's the value of this? Yeah, ln, absolute value u plus c. Okay, last step. Plug the u back in. Good. Okay, that's always the last step. Okay, so you plug that back in. So your final answer is going to be 1/3 ln x the third minus 3x plus 7 plus c. So that is your answer. Okay. Now let me do a check on this one, then I'll just kind of give you time to do a couple of these. It's the only way to see if you can do it, is just give it your best shot. So if we do the derivative for checking, okay, how would you do the derivative of my answer? What would you do with the 1/3? Just bring it down. How do you do a derivative of ln? 1 over the function, right? Then what? Derivative of function, which is what? 3x squared minus 3. And of course, you got that. Now, look at the problem I gave you. Is it matching up with a little bit of simple algebra? Yeah, okay. One way to look at it's like this. Okay, you'd have 1/3. You'd have 1 over x cubed minus 3x plus 7. You can factor a 3 out of that to get 3 times x squared minus 1, and the 3's cross out. Now we're back to the beginning, see? Look at that and look at the original problem. Okay? That's how you tell you're right. Okay? Now that's a good thing to learn how to do when you're doing integrals and stuff on your homework. Check them. That practices your derivative skills. It helps you understand and reinforce what you're doing anyway. Okay? Okay, so I think let's go ahead and I'm going to just give you a little bit of time to see if you can put these together. I'm going to start you off on number 1, and then I'll just kind of let you do all the 2 on your own. Let's just kind of see. What do you think would be a good thing for you on number 1? Okay, let's try what you're suggesting. So he's suggesting x to the 4th plus 16. Okay, that's going to be the u part right there. We're going to replace that part with u. Okay, what is du? And then what else? Okay, is that matching what you want?
No.
No, it's got to be x cubed dx. Take it from there and then try to do the second one. Okay? It's the only way to tell if you can do it. Just roll up your sleeves and do it. Remember, if the du doesn't match, if it's off by just a constant, a constant being multiplied, then you can generally go through and deal with that. Now I'm going to go ahead and finish up this number 1 because I'm about out of time here. So, all right. So what you need to do with the du is divide by 4. Okay, that way the x to the 3rd dx matches what's left over. Okay, so if you do that correctly now, what you'll have, your integral will be the yellow part's u, so you'd have u to the 6th. The blue part is 1/4 du. That's the integral that you're going to end up working with is that. Okay, once you get everything, the u and du substituted in, do your integral. You can bring the 1/4 out, so you'd have 1/4 integral u to the 6th du. Okay, what that's going to leave you is 1/4 u to the 7th over 7 plus c. Okay, that's what you'll have when you do the power rule. And then the last step on the problem is just plug back in the u. The u is x to the 4th plus 16, so that plugs in there. And then if you multiply 4 times 7, you would get 1 over 28 times x to the 4th plus 16 to the 7th plus c. That'd be your answer. Okay, there's different ways you could write that. You could have the whole thing over 28 also like that. But the idea is dividing by 4. That's what you got to do so that everything's accounted for. Okay. The last one, the way to do number 2 is to let u be the denominator, 5t squared plus 2. Okay, and then you can take the 20 out. What I was trying to show you on this is it's best to take the 20 out first. So we're kind of hoping that du will be this thing, the thing I've got in blue over here. So notice that is 10t dt. Okay? So see what I got. I got the u. That matches. Now how do you make the 10t turn into just t dt? By 10, right? Okay. So if you do that, both sides, what you would end up with then is you would have 1/10 du equals t dt. Okay, it's a good idea to take the 20 out first because you'll see it better. So that's u, and then the t dt is going to be 1/10 du. So see, everything's accounted for. You have the u being this piece, that matches, and then you got the 1/10 du as this. So what you would end up with is the 20 is the constant. You would end up with t dt changes into 1/10 du. over u like that. And you have a 1 over u integral, which is easy to handle. So what you would do is bring the constant out. So you'd have 20 times 1/10. Then you'd have integral of 1 over u du. Then you can finish it up. So what happens is 20 over 10 is 2. So you'd have 2 times the integral of 1 over u du. Okay, and that's pretty easy. That's ln. So you'd end up with 2 ln of u plus c. Then you just plug the u back in. So u is the 5t squared plus 2. So the final answer is going to be 2 ln 5t squared plus 2 in absolute value plus c. That is your final answer. So when you do your homework, you'll probably start off with the simpler ones. And once you get the simpler ones under control, all you're going to encounter on these is that du, you usually have to divide it by something to get it to match. Okay? Takes practice like anything else. You just got to go for it and work with it, okay? All right, so we'll wrap this up next week on Monday.
Should we take the review for the test?
I already gave you one right there. I passed it out.